Hello, welcome back once again. In our today's video, we're going to solve the following interesting exponential equation. And we are going to solve for the positive integer x that will satisfy this equation, right? Okay. Now, since we're looking for positive integers, we know that x cannot be greater than 4. If x is equal to 4, remember that 6 to the power of 4 is far away greater than 251. Imagine only 6 to the power of 4 being greater than 251, and we're still adding 2 to the power of 4 plus 3 to the power of 4. That would be far bigger than this, right? So we know x must be less than 4. Now think about when x is equal to 1, so we get 2 plus 3 plus 6, and that is 11, which is not equal to 251. Imagine when x is equal to 2, we get 6 to the power of 2, which is 36, plus 9 here, which is 45, then plus 4, which is 49, which is not equal to 251. Right? Okay. When x is equal to 3, that is when we have our solution, right? So we can see that x is equal to 3 is our right answer. But how can we solve this problem? Now I found a very interesting way to solving this problem. Let's start. From the left hand side, we have 2 to the power of x plus 3 to the power of x plus, now 6, we know 6 is 2 multiplied by 3, then everything is raised to the power of x. This is equal to 251. We know this property that when we are multiplying a and b and we have a power of n, this is same as a to the power of n multiplied by b to the power of n. So from here, we have 2 to the power of x plus 3 to the power of x plus 2 to the power of x multiplied by 3 to the power of x. This is equal to 251. From here, let's rewrite as follows. This is going to be 2 to the power of x plus, here we have 2 to the power of x plus, multiply by, sorry for that. So multiply by 3 to the power of x, then plus 3 to the power of x. This is equal to 251. From here, we can see that 2 to the power of x is common, so let's factor it out. So if we factor it out, we are left with 1 plus 3 to the power of x. Then we have here plus 3 to the power of x, and this is equal to 251. Now, in our next step, we're going to add 1 to both sides. So we have here 2 to the power of x into bracket 1 plus 3 to the power of x plus 3 to the power of x, then plus 1. This is equal to 251 plus 1, which gives us 252. Now we can factorize the left hand side. We can see 3 to the power of x plus 1 is common. So let's factor it out. So here we're left with 2 to the power of x plus, here we're left with 1. And this is equal to 252. Okay. Now 252, we can express it as a product of two numbers in a couple of ways. We have 2 multiplied by 126. So we have 4 multiplied by 63. We have 9 multiplied by 28. We have 3 multiplied by 84. So we have 12 multiplied by 21. We have 36 multiplied by 7. We also have 1 multiplied by 252, right? So do we have more? I don't know. But all I know here is that only these two products we provide the integer solutions. The rest of these products will only give us real solutions that are not integers. Right? Okay. So now let's get into the main stuff. Okay, now from here, we know that 3 to the power of x plus 1 is greater than 2 to the power of x plus 1 since x is an integer, right? Okay. Both all real values of x, I'm very sure this holds, right? Okay, now from here we have this product, 3 to the power of x plus 1 multiplied by 2 to the power of x plus 1, which is equal to, so 256. We have only this to give us our real solution, our integer solution, I mean. So that's going to be 9 times 228. So since we know that this is greater than this, so this implies from here that we're going to let 3 to the power of x plus 1 equals the bigger number, 28, and we're going to let 2 to the power of x plus 1 equals the smaller number, which is 9. Subtracting 1 from both sides, in each case, we get 3 to the power of x is equal to 28 minus 1 is 27. And from here, we get 2 to the power of x is equal to 9 minus 1 is 8. From here, we have 3 to the power of x is equal to 3 to the power of 3. Yes, we have here 2 to the power of x is equal to 2 to the power of 3. So from here, we have obtained equal base from both sides of the equation. So this implies from here that our integer solution is 3. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.